Hello friends, welcome you all. Today we will start our new unit, that is unit number 3. From this unit number 3 we have to achieve the course outcome number 3, that is analysis and design of singly reinforced rectangular beams. Okay, so let us see unit number 3, that is analysis and design of singly reinforced sections. So we have weightage of this unit is 12 marks and we have to complete it in 14 hours. So what are the points which we have to discuss in this unit? Let us see one by one. That is function of reinforcement. Second one is the use of IS 456 2000. Then steel grades, that is Fe 250, Fe 415 and Fe 500. Then types of limit state, that is limit state of collapse or flexure and limit state of serviceability. Then the characteristic values, that is characteristic load and characteristic strength. Then partial safety factor for steel and concrete. Then types of load on the steel structure, that is live load, dead load, then wind load, earthquake load, snow load. Then we have to discuss the assumptions, various assumptions which are assumed for the limit state of collapse or flexure. Then stress strain block diagram for singly reinforced beam. Then some different parameters and design constant for singly reinforced section. Then types of RCC sections, that is under reinforced section, over reinforced section and balance section. Then IS specification for the beam, that is as per IS 456 2000. And lastly we are going to discuss analysis and design of singly reinforced beam, that is some numerical problems we are discussing or solving. Okay, so after studying these all points, the student should be able to choose the partial safety factor as laid in the IS provision for the given situation, or the explain the different types of loads acting on the RCC structure, then describe the procedure used for limit state method of design and RC members. Then they should be calculate the ultimate moment of resistance for the given type of sections. Then design various beam sections for the given condition, that is singly reinforced sections, and also the draw the reinforcement detailing for the given element as per the IS provision, or they should be identify the given section as under reinforced or over reinforced or balanced section. So after studying this unit number 3, students should be able to achieve these some course outcomes. Okay, so let us start point number 1, that is definition of RCC. So before going to discuss the RCC, first of all we know the what is meant by concrete. So concrete is the mixture of cement, sand, aggregate and water. So this concrete is a very good building material. So the structure of concrete become a very common in civil engineering construction because the concrete has the advantage of being molded into any desired shape most conveniently. Okay, and it is an artificial stone like mass obtained by mixing aggregate, cement and water. So the what we can say, the strength of concrete depend upon the quality of its ingredients, their relative quantities and the manner in which they are mixed, compacted and cured. Okay, so these concrete we are categorized as PCC and RCC. Okay, so this PCC means plain cement concrete and RCC means reinforced cement concrete. So how we can define this RCC? So this RCC is the composite material, we can say, made up of concrete and steel. Okay, so it is the composite material made of concrete and steel. So this cement concrete possesses the high compressive strength but weak in tension. Okay, so this low tensile strength is compensated by use of steel reinforcement, and thus the concrete is strengthened, or we can say the reinforced by steel, and the resultant composite mass we are knowing as the reinforced cement concrete, that is RCC. Okay, next point is the functions of reinforcement. So first one is function of reinforcement is to carry the direct and bending tensile stresses. Okay, so in case of slab beams and walls of the water tanks, the reinforcement is mainly provided to carry these direct or bending tensile stresses, and hence it is called main steel. Okay, so it is provided on tensile face of the member and away from the neutral axis. So here we can see the one beam, we can see here, that is simply supported beam. One end is supported hinge support and other is the roller support. If suppose we are assume the some load that is concentrated or UDL act on this beam, so this beam may be sag like this. Okay, so there may be a compressive stresses develop on this top surface and the tensile stresses develop in this bottom surface. And we know the concrete is very weak in tension, so to avoid the crack at the bottom face of this beam or to tensile failure of this beam at the bottom fiber, we are providing the reinforcement at the bottom. Okay, so to resist the tensile stresses. So the main function of the steel is what? To resist, to carry or to resist the direct or bending tensile stresses. Second one is the to resist the direct compressive stresses. So in case of column, the steel is provided to resist the direct compressive stresses as well as bending stresses, if any. The steel provided for this purpose is known as main or longitudinal steel. Okay, so here we can see the, suppose this is the short column. Okay, short column generally fail by the crushing and the long column fail by the buckling. So this in this short column we are providing the vertical reinforcement, that is the longitudinal bars, we can say, to use to carry the resist the direct compressive stresses. Okay, or we can say the main steel. Okay, this longitudinal steel we are calling as the main steel. Next is the to resist the diagonal tension due to shear. To in case of beams, stirrups are provided to resist the diagonal tension due to the shear and hold the main steel in position. Here we can see. Okay, due to the shear, this uh, diagonal cracks we can call as a shear failure. Okay, okay, due to the excessive load, beam may fail in the beam may be fail in a diagonal tension, that is in shear. Here we can see that due to this load, 2 point load, the beam fail in a shear in at the supports. Okay, so to avoid this shear failure of the beam, we are providing the vertical stirrups in beam. Okay, that is a transverse reinforcement we can call as in beam, that is in the form of stirrups we are provided to avoid the diagonal tension due to the shear. Next is to resist the spiral cracking due to torsion. Okay, so the box type mesh of reinforcement is provided to resist the torsion. Here we can see the box type, that is the longitudinal and the transverse steel, that is the stirrups we are providing, that is mesh, box mesh, we are reinforcement is provided to avoid this diagonal tension, spiral cracking due to torsion. So next is the to prevent the buckling of main bars in column. As we are discussed earlier, long column fail due to the buckling. Okay, so to avoid the buckling of this longitudinal bar, we are providing the lateral ties in the form of rectangular, circular or lateral ties to prevent the buckling of these main bars, that is longitudinal bars in column. Okay, next is the to distribute the concentrated load and to reduce the effect of temperature, that it is provided in the form of distribution steel. The function of this distribution steel is to what? Is to distribute the concentrated load and to reduce the effect and temperature and shrinkage and to hold main bars in position. Okay, so here we can see this is the reinforcement in slab. Okay, so this is the um, distribution steel we are looking for. Okay, this is the main steel. Okay, and this is the distribution steel. So what is the use of this distribution steel? To hold this main steel, okay, and uh, to hold this main steel into the position and to distribute the or reduce the effect of temperature and shrinkage, okay. So these all are the functions of the reinforcement, okay. Next is the advantages of reinforced concrete. So first advantage of reinforced concrete is the constituents of RCC are easily available. So what are the constituents we are using for RCC? That is cement, sand, aggregate, water and steel. So these are the easily available. So this is the advantages of reinforced concrete. Second one is the reinforced concrete has a high compressive strength compared to the other building material, okay. We are knowing the concrete is the very high compressive strength and still also having a very high compressive strength. So RCC sections become a very high compressive strength other than the building material, okay. So also it having the good tensile stress, okay. We know the concrete is weak in tension, but due to we are providing the reinforcement into the concrete can also withstand a good amount of tensile stresses. So this is also the advantages of these RC sections. Next is the concrete can be easily molded to any desired shape, okay. That is we are mold it into the circular shape, okay, parabolic shape, then the rectangular shape. So we can easily mold any desired shape using the concrete, okay. So next is the it is the durable one. We know the concrete structures are very much durable as compared to the steel structure, okay. Minimum life of the concrete structure is 30 years, okay. So it may be up to the 100 years. So it is a very much durable one. Next is it can be made watertight, okay. We are using the elevated service wire using the RCC. uh, RCC store the water, okay, or to store the oil. We are also using these watertight concrete structures. Next is it is a fire resisting, okay. Next is the maintenance cost is very low, okay. So as compared to the steel structures having the periodic maintenance, okay, that is the anti-corrosive painting, okay. But in case of RCC structures, maintenance cost is very low, okay. That is negligible one, because if once we are construct the RCC structure, minimum 20 to 30 years, it doesn't have any severe cracks, okay. So maintenance is very negligible as compared to the steel structures. So hope you will understand today's session. Thank you.